Okay. All right. Hello, everyone. Welcome to the class. So, I'm really sorry to mentioning uh, just this thing around 4 p.m. I mentioned in the Moodle that we are going to have the online class. Yeah, this because I think I have a little bit fever, but not really that bad. But I think because of the weather also, so I decide not to going outside. Okay, so um, what I want to do in today's class is review. First is review the polynomials. Okay, some maybe check some questions, how to respond to particular questions, and that will be maybe around 30 to 40 minutes. I hope we can have time for that review. And after that, we can continue on this exponential functions, and next is logarithmic functions. We're going to finish by today. So my goal today is review the polynomials, finish the logarithmic functions, and also some property like the exponential, the logarithmic, uh, and also if we have time, we can have some practice or exercise about this. And that's for today. So next week we are going to move on to another chapter. So before we are going through, let me going through uh, some information. Okay, perhaps I think I've mentioned also in Moodle and also in the previous class if you watch the video. So in the video, I explained that the basic math, our course, we don't have any midterm. So no midterm. Okay, so don't worry about that. So no midterm. So no midterm. So what we have is first is quiz. Okay, so quiz. We will have several quiz. So we have done last time, right? And the next quiz after we finish this today's class, maybe at the weekends or maybe next week, I will also put some links for another quiz. Okay, so next quiz, perhaps this is going to be next week. It's online, so you don't need to worry about that. So online quiz next week. Um, yeah, so it's first week of November. And of course, I will let you have freedom to choose which day you are going to take the quiz. So I will give you like 5 days, okay, 4 or 5, yeah, probably 5 days. So I will give you 5 days to complete. The topic for this quiz, okay, the topic, this will be the polynomials, okay, and the uh, the exponent and logarithmic functions. Okay, this will be next quiz next week. So around um, not first week, second week. Sorry. Supposed to be second week. Second week. The first week is today, right? The second week. So maybe around 8, 9 November. Okay, so you just keep updated on Moodle. Okay. Okay. And yeah, I believe this is information that you need to get. And oh yeah, also on December, since uh I have been talking to you before, I think I explained in the early classes that we are having a PBL method for the class. I'm not sure how we are going to work this out, but I think on December we are focused on our PBL method, which means that I will give you before the class maybe some text like PDF files that you need to read or yeah, to keep in mind. And then in the class, and supposed to be um, some classes will be offline classes. So we are going to have more on offline class on December. This will be focusing on PBL method, and the students supposedly to be more active in class. Okay, so I will give you some like a procedure, and you are going to have a group discussion, and every group will each group will not really a presentation, but maybe give some explanation or some how to yeah, like solving problems, okay, how to solve the problems, and um, yeah, pretty much solving problems, okay, solving problems or explaining some topics. Okay, and the topics I will let you know. I think in the middle of November. Okay, for some topics that we are going um, to discuss on this PBL method. So at least two classes where we are going to have the PBL method, and yeah, I think that's it. Okay, that's it. So this is just my introduction for um, some information that might be important for the next couple of weeks. Okay. Okay, I think now we can follow up our review. It's this polynomial. So let me give you a question, and you can also start working on it. So let me check the documents first. Okay, maybe giving you uh, the finding the zeros. Okay, I think that will be a typical question in polynomials. Uh, okay, uh, okay, I think I have the question. Okay, let me start with review. So first is we learn about the finding real zeros, right? Finding real zeros. So let me give you the polynomials function. So suppose our let the px is equal to x to the power of 4 plus x cubed plus 2x squared minus 3x minus 2. Okay, so find um, all zeros of p, and maybe state their multiplicity. If you remember multiplicity, this is if they have a duplicate. Okay. And of course, the duplicate also considered as another zeros or wait. Okay, wait. I think it should be okay right now. Anyone who are unable to see? Is everyone not really see anything? Uh, okay, maybe. Oh, it's clear now. It was bad. Good now. Okay. Oh, wait. Maybe I will move this here. Okay. Okay, so now it's okay. Now it's okay. It's clear now. Okay, I'm not sure what's happened, but I think it's because okay, yeah. Okay, let's continue. Okay. Uh, and probably sketch the graph, but probably this sketch the graph questions is not really will be in the quiz because I'm not sure how to sketch the graph, but maybe selection from some picture, maybe that will be one of the questions. Sketch the graph B. So two questions about from this polynomials. Okay. If it's if you cannot see anything, or maybe there is like a significant delay from the uh, sound and the screen, please let me know. Okay. Yeah, yeah. I think this is because of the setting. Okay. Okay, you can try for a couple minutes finding the zeros, and uh, if they have multiplicity, how many of them that have multiplicity multiplications, and then if possible, sketch the graph of this polynomial p. Okay, what's the first thing that we need to make out from this polynomials? The first thing is we are going to approach from the very left or the highest degree, okay, the coefficient. Okay, so we are starting from this 2, okay, we identify that, and the last coefficient, okay, without any the constant, the constant. So we state that this will have a possible zeros or possible rational zeros, factor of 2 divided by factor of 2, which means that this is going to be uh, this p over q, okay, p over q. So this will be factor of 2 is plus minus 1 and plus minus 2, and this is also the same, right? Okay, what's next? Next thing is, let me write the polynomial again here. We can move on to the Descartes rule, okay? To Descartes rule. Well, the Descartes rule is actually optional. Okay, you can skip if you want. If you think that you can figure out what kind of zeros you can have, but if not, then this is a good way to narrow your predictions. Right? The first is we uh, we mention or we marks our uh, change in sign. For example, this is positive, this is negative, so it's going to be changing here, right? So one change, right? So it's supposed to be having one positive zeros or one positive real root, right? Or zeros. And then the negative root, we can check if we plug in the negative x. So it's even, so it's same. It's odd, so it's become negative. It's even and become odd, and then negative 2. So we have 1, right? We have changed again from negative to positive, and then we have change here, right? So we can say we have 3 negative real root. And remember, whenever you are having more than 2, we must have another possibility that it will be 1 negative real root. If you have 3, it's supposed to be 1. So you can imagine if we have 4, it will be having 2, and it will also having 0. So they are all possible. Okay. Our goal to find the roots that that has 4. Okay, so we have 4 roots because we have 4 degrees, right? We have 4 degree of polynomials, right? So we have positive, negative. So we are going to have for sure the positive real root. That's for sure. So 1, 1. Okay. So for sure, and the negative root, it can be 3, it can be 1. So if we total this, the total of the root, this will be 4, right? It's the same as we have in the questions in the polynomial degree, it's 4. But in the second line, we have just 2. Where are the other 2? The other 2 will be the imaginary. The root will be having a complex, not imaginary, maybe a complex, conjugate, complex, conjugate. It's still, as a whole, it's a real root, but it has an imaginary number, okay? So it will be having maybe another 2. So the total, it's supposed to be 4, the same 4, okay? But this is not fixed answer. So this is just our assumption or prediction, okay? So it can be following the first steps or following the second step. Okay? So what we are going to do next is we are going to focus, because for sure it has positive 1 for the real root. So we can find the real root from all the positive roots that we have from here. So we are going to have plus minus 1, or let me write all the possibility, plus minus 2 and plus minus half. So we check all the positive roots. So positive root will be 1, 2, and half. So we check these 3 numbers. So we check using the syntactic division. So use syntactic division. So the question is 2, 1, 2, -3, and -2. Okay, this is the x4, x cubed, x squared. This is x. This is a constant. Okay. Now let's take our syntactic division, and we start from 1. Okay, we start from 1. So we move this 2 down here. We multiply with 1, put 2 here, and plus this 2 and 1 is 3. The same thing goes on. So this will be 3, and then 5, and then 5, and then 2, and then 2 here, and this will be 0. Okay. Now remember that this, when we have 0 at the end, let me also remind you that this is called the remainder. Okay. How many numbers that still remain in the in this last row? So it's called remainder. If it's going to be 0, it which means that 0 means that the division process is complete. Okay, so it's completely divide the number, the roots, okay, and it's becoming 0. So it's going to be a complete um, complete division. Okay, complete division. If we still have remainder, then we are not dividing completely. So we have the remainder, and we need to maybe just to rewrite that. Okay, but since it's 0, so we sure that this 1. Okay, so x equal 1 is real root. Okay. So the next thing is, so we now have this real root, 1 positive real root. The next thing is checking the negative number. Okay, checking the negative number. Okay. So we can check -1, -2, and -half. Okay. Okay, and we can start from writing the p of x. This can be x minus 1, and we can rewrite using the new equation here, 2x cubed plus 3x squared plus 5x plus 2. Okay. Now we can start the synthetic divisions from here. Okay. We can start from here. So let's do that. And also, if you carefully um, observe that this P and Q is also having the same factor. Okay, having the same factor. But nevertheless, we are going to check the negative root. Okay, so we're going to write 2, 3, 5, and 2. Okay, and also if you check using the Descartes rule, there will be 0 positive, right? Zero real root, right? And if you check using the negative x, put inside this x cube, we are going to see several number of negative roots, right? So we check through here. So we divide this. So first we can check negative 1. So we check, and then we still have negative 2. So it's not our best choice. So we check with another one. So try negative 2. Also not 0 here. So not our best options. Another number is negative. Oh, okay. Negative half. This is going to be 2, negative 1, 2, negative 1, 4, negative 2. Okay, 0. So if this is not our 0, so this is not real root, not root, not root, and this will be root. So what else do we have? What option do we have? Perhaps there is multiplicity. So you need to remember when you have this and you think that maybe I have the root. So the positive root is already done. So where are the other root? Okay. Remember, we might have multiplicity. Okay, we might have multiplicity. So we might have. So let's write down all the component. Okay, for the factors. So factors is x minus 1. For the first one, there's positive root, and then x plus half. And we have 2x squared plus 2x plus 4. And I think it's not multiplicity, but rather it's because we call this irreducible factors. So we are just stuck on this form. We cannot do anything about this because this is if we take out the 2, if we try to factor out, this is something that we cannot factorize. And if you try to find out how it is, we are going to have, so this is supposed to be, if we have x like this, we are going to have at least half, right? Half squared, or this will be x plus half squared. Okay, and because this having 2, so you will see that perhaps this will be going to have a conjugate. So I think we can finish off this by taking this into, well, I don't think we need to solve this, okay? Uh, yeah, we can just leave as it is, okay? Leave as it is. But if you want to make out the other roots, that's okay. But the questions is just asking the real root. And to sketch this, we can sketch the uh, we can sketch the 1 and negative half. So maybe negative half is here, and 1 is maybe around here. Okay. And since we are having the polynomial of degree 4, then perhaps that this is going to be like that. Maybe not really a good way to draw. Maybe a little bit like that. Okay. Yeah, more or less. Okay. But I think the sketching graph is difficult to do um, in online exam. So yeah, I think the question will be around the zeros and multiplicity, possible roots, the positive, the negative roots, how many positive roots that is possible, how many negative roots that is possible. I think that will be the questions around that question. Okay, let me give you yes for the quiz. So for the quiz, the question is probably not really asking the sketching part, how to that's the sketching graph, but maybe asking the roots. Okay, the quiz will be next week, um, maybe around from after the class next week. So I will give you maybe 4 to 5 days, or maybe yeah 5 days, maybe from Wednesday to Sunday to work on the quiz. You can choose which day you are going to work. Let me give you another. Okay. Mm, Let me give you another questions. Okay. Okay. No question on here. Okay. If you want to take notes, I think it's okay to take notes. Okay, let me move to the next page. Okay, and give you another. You can check this later on. Okay, you can check this later on. But let me give you another example. So we have functions. Let f of x is x cubed plus, let's say we have p x squared. Okay, and then we have qx and then plus 6. Okay. The question, okay, find p and q if x minus 1 is a factor of f of x. Okay. And when f of x divided by x plus 1, the remainder is 8. That's the first. And then the second one, the follow-up question is solve equation of f of x equals 0, which means it's going to be finding the roots from the, so first is finding the value of p and q. The second question, if you have find all, then you need to find the roots of the equations. Solve the equation, meaning you need to find the x. Okay, let me give you a couple minutes, 3-4 minutes, just to check, um, where you will be, uh, um, so, what's your directions, where you will be going from this question. I just want to know, and if you've done, please write the answer, the P and Q, at least the P and Q, you get the P and Q. Please write in the chat box, okay? The number of the P and Q, what number it is. Okay. Anyone have the answer? We first need to understand the question first. Okay? First, it says that the x minus 1 is a factor of f of x. So x minus 1 can be a factor in here. Okay, all right? And if you divide f of x with x plus 1, and you have remainder, this will relate to what we call remainder theorem. I think I mentioned this, just a brief, I think couple weeks ago. I think last week or last 2 weeks in the videos. So I need to make sure that we can use that in some questions like this. Right? Okay, anyone get P and Q? But do you understand the question or confused? Let me know if you're confused. Okay. Okay. Okay, I'll wait another 2 minutes, another 2 or 3 minutes. Okay, anyone? Okay, okay, good, good. Okay, good, Jennifer. Okay, now uh, let me explain this question. Good answer, Jennifer. That is a correct one. So to get the full idea on what this question means, okay, uh, the remainder theorem or the well, yeah, remainder theorem. Okay. So if we have a px something, okay, if we have some, if you plug in x equals something, like say -1, okay. So p -1, if this become a zero, if this become a zero, it means that this is a root, right? But if, for example, if we have maybe 3, okay, this is just a random number, okay, don't worry. And if we plug into our function, if we have this 5, it means that it has something left, right? When we plug in, not 0, which means that this is going to be our remainder, okay? This is all going to be our remainder, okay? So these functions here, we can see it from a perspective that when we did the syntactic divisions, remember? So let me write the functions. Okay. X minus 1 is a factor, which means that x equal 1 is root of f of x. Okay. Root means, remember, when it is root, then when we plug in 1, it's going to be 0, right? So when we plug in 1, it's going to be 0. But we are not sure of p and q. That is the one that we are looking for. So we just plug in 1, plug in all. It's not having the bracket here, sorry. It's qx like that. And then plus 6, okay? And this is equal to 0, okay? Why 0? Because it's a root, okay? And the other thing is this x plus 1, okay? So x plus 1 is, we check x equal -1, okay? So when we check x -1, remainder is 8. So f -1 is -1 plus px, p, okay, and then negative q plus 6. This is equal 8. Okay. Now we have a linear equations to solve that we need to solve. We have this and we have this. So let's solve that. So p plus q is equal -7 for the first one, and p minus q is, it's 5, 8 minus 5, it's 3. Okay, we can plus this 2, so we have 2p -10, and p is uh, oh, why I'm -10, sorry. It's -7 plus 3, sorry, it's 4. So p is -2. And then because p is -2, then q is -5. Okay, so that's it. Well, you could also try because you know that this x minus 1 is one of the factor. Then you could try to, well, you could try both sides and force these two into a syntactic division, and eventually you will get the same linear equation like this. Okay. But I think if you check through the syntactic divisions, it will be very troublesome when you check with the variable p and q as in your process. So I think better just to use this remainder theorem, okay, just to check. Okay. Okay. The follow-up questions. Then we take the f of x, that our f of x become x cubed -2x squared -5x plus 6. Okay, and we know that we are going to have root in x equal 1, so we take into the syntactic division, and it's going to be equal to 0. Okay, the remainder is 0, so it's going to be having this another equation. So we have okay, this is, so if you want to solve this, find the x, we need to equaling this to 0, and I think we can solve this into factorization, right? So we can have this x plus 2, x minus 3. So we have x equal 1, x equal -2, and x is 3. Okay. Okay. All right. Okay. Okay. Any questions about this? Any questions? Okay. So I think after this class, maybe on Wednesday or maybe Thursday, I will give you another Well, it's not homework, but maybe exercise. Exercise just to make sure that we understand this polynomials, especially finding the zeros, and then how to narrow the process, the Descartes rule, okay, um, and the remainder theorem, okay. So that will be in uh, in the quiz, okay. Okay. There are no questions. I think we can move on. Okay, we can move on to next uh, part in our chapter. Uh, we have been into the exponential, function, and we are going to move to the logarithmic. Okay. Okay, let's start. Uh, okay. Okay, if there's no question, let me move the page. Okay. All right. We have discussed a little bit about this exponential, and we've come up to um, the solutions of the Euler number, something that is in between 2 with power of x and 3 with power of x. We have something that we call with e. Okay? So this is called the natural. Oh, let me just write logarithmic later. We'll write first that this is the natural exponential function. So the base is e. Okay, the base is e. E is a specific number that when we try to find out how it is when we deal with this 1 plus 1 over n with power of n, when we increase n as much as we can, it will reach out eventually it will reach out, getting close to this e. Okay? And e also can be used for what we call the natural logarithmic. Okay? When we have the ln, that is the natural logarithmic. When we have the e, the result of the L and E, it will be 1, okay, as we are going to see next in the next sections. And one of the interesting in exponential is this. Okay, so when you have this, okay, when you have uh, the base 3 with power of x, the opposite side is 3 with power of negative x. So you can also see that this is a mirroring through y-axis, right? The same thing with e. You can also do the same thing, and it will be very useful in the. Oh, I don't have that. Okay, later. So e is e like that, and the other one is like this. Okay. So this will be e with power of x and e power of negative x. Okay. So this will be e negative x. This will be e power x. Okay. This will be very useful in our observation, in especially in calculus problem. Okay, let me move into the logarithmic function. So we move to logarithmic functions. The logarithmic function. So remember that if we have uh, f of x, let's say it's equal y, we can rewrite this as our inverse, right? Like that, right? This will we have done this in the first chapter, right? In the function. Now we can think the e to the x as the inverse of the log, okay, as the log. And if we check for just for random base, okay, let me just throw out a random exponential. So let's say this is a with power of x, like that. Okay. We know that if we check with the horizontal line, this is going to be one-to-one functions. Okay. So we can have this with the inverse. Okay. Okay. Now, if we write with the definitions that, let's say, y is a to x, or let me rephrase this into in more a good sense in the logarithmic functions. Let so that we have another one. Okay, so let a to the y is equal x. Okay, let me change x and y to make it um, beautiful for the logarithmic form. Okay, so if we want to change the form into log, this is the base, and this is the result of the power, and equal the power. Okay, so this is the power, this is the base, this is the result, right? Okay, I hope it's clear. So if we have uh, 10 with power of 3, this is going to be let's say 1000. We can write this in terms of log, that we have log base of 10 of 1000 equal 3. So we can write down the um, the exponential as log form. So what's so special in log? What is so special? Why this is something that is really useful? Because if we take the log, okay, the important thing in log is we are going to take this power into our usual number. So we can take down, right? We can take it down. So if we take this 3 into here, so what's the impact? The impact is if we have for some reasons, let's say we have the the amount of data, because we have a data set. Let's say we are going to have like 10,000 and then 1 million, blah 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 blah, and it's increasing exponentially. So if we want to make uh, uh, we reduce the scale, so we want to use the new scaling, then we can use the log, like in chemical we are using the pH, right? The pH is one of the application of log that is really practical, really helpful, and it will be going to make the computations easier, and to give some insight for analysts, okay, so that they can really see what's happened. That's the law. So let me give the definitions here. Log is this. Well, sometimes I'm switching this y and x, but it's still the same. It's still consistent. I hope you're not confusing. See this different form, okay? As long as it has some explanation like this. Okay. Okay. Now, another important inverse property, that if we have f inverse and we put our, let's say, f of x like that, this will equal to x. Or if we take f and we put our f inverse, this is also x, right? This is from the chapter, early chapter 2, right? The inverse function property. So the same thing here. So if we take, let me write here, if let's say the f of x is a power of x, okay? And if you want to make sure that our statement are correct, that when we have the log a y, this is equal x, okay? This is y, okay? So we can check this, and we can exchange y. We can exchange y with a to the x, okay? And this is true in some sense. In logarithmic property, this log a is 1, right? Because a, the reason is because a, we need to raise this with some power, and it's equal to a, and of course this is just 1, right? Okay. So if we take this with power of x, to make this becoming x, so we need to raise this with x. So it means that this will be equal to x. Okay, so that means it's going here. Or the simplification, or the shorter way to look at is, we just having, if we have something in power inside the function of log with some base, we can think that this power can be transferred here in the front. So we are going to have x log base a of a, and log a base a is 1, so it's just equal to x. Okay, same way of thinking. So you can think with those perspectives also. And also the same thing, if we want to plug in the inverse into the functions, so this will be log with base a and x. This is also x. Okay. So this is becoming two important property in log. Okay. And if we draw the graph, let me draw the graph here. So we can say that this is our, let me copy. Uh, okay. Okay. So we can simply say that the exponential is the inverse of the log, or we can say otherwise, the reversibly, the log is the inverse of the exponential. And of course, because of the transformation in log will be the same with exponential, all the things in exponential that we have done before, it also happened in log. So you can see when log has some mirroring, you can mirror the log, mirror to y-axis, mirror to the x-axis. Okay. And also the number 10, this is, we say that the number 10 become the base of a common logarithm. We say it's common logarithm. So what does it mean? So sometimes if this is in base 10, we are not really writing the base. So if we say log of 10, it's actually log base 10 of 10. But we didn't say the base. So we just say log 10, log 100, and so on. Why is that? Because 10 is our common base in computations. Okay? In all computations, the base is 10. If we change the base, then we are changing the principle of our calculations in our universe. Okay? At least in the mathematics world. It's simply like when we calculate or adding and subtractions, we sometimes using our hands, and we have a 10 fingers, right? 10 fingers in human. That's actually one way to think that that's why the base 10 is become our common logarithm. But maybe we can talk that if we have time. Okay. Um, I think we can go next. Uh, okay, we go next to the natural logarithm. Do I have the, yeah, this explanation? Okay. Wait, not exponential. The logarithm. I don't have that. Okay, anyway, the natural logarithm. Let me just write. So logarithm with base e is called natural logarithm. And we are saying that this ln x is actually log with base of e of x. So we can simply say this log with base e with terms ln, natural logarithm. So if we have ln x equal y, it means that this e with power of y equal to x. And of course, by these implications, we have, if we have ln 1, it means that it will be 0. So because we need to raise e with power of 0 to become 1, right? And if you have ln e, this is become 1, right? And if you have ln e with power of x, okay, since we can move this x to here, and ln e is 1, so we are going to have x, okay? And if we have e with power of ln x, we are going to have x. Okay, now because we talking about functions in log, okay, in log forms, so finding the domain also becomes critically important also. Okay? So example, if we have a function that is ln 4 minus x squared, okay, to find the domain, that whenever we have ln, the inside here, this inside, we need to make sure that it's going to be positive and never going to be 0. Okay? If you think carefully what we have in the graph here, that the log or ln, it will never reach any 0 here. It will have the asymptote, the vertical asymptote. So x, maybe different color. This is vertical asymptote. Okay. So we are never reach 0, okay, in the log. So this is becoming more logical, right? It has greater 0. So we are going to have that this is going to be greater 0. And we can solve this. And remember, okay, whenever you feel confused on how we are going to write which interval that is going to make it out of this, okay, unless you are familiar, you are really good about this inequality, I think it's still okay if you just draw the line numbers. Okay, draw the line numbers, write all the possibility that is -2 and 2, and then it's just checking the numbers. So checking 0 is positive, checking negative, okay, it's become negative. It doesn't hurt, and just to check this. Sometimes if we just do it in mind, or maybe with some computation here, writing here, maybe we've made mistake. But if we narrow it with the line numbers, we can see clearly that okay, we have a positive one here, that is we are going to need, right? So that's our domain. So domain will be, and remember, the bracket need to be open. Okay, open, because we don't want to this number to be inside our function. Because when we have this 2, this -2 and +2, the function become ln 0, which is not defined. Right? Okay. If you feel you need to review some parts from the previous page, just let me know which part, or maybe you need to catch up some writings. Let me know. Okay. Now let me give you some law of logarithm that is basic, the basic one. So whenever we have log, okay, we have log of a, if we have multiplication inside our function log with base a, let's say we have a, b, and we can separate them. And also when we have the fraction, we can also separate them, become minus. Well, we could just take sometimes to prove. Okay, if we want to prove this, so let the log with base of a, let's say this is u, and log with base a of b is v. Okay, we can write this in terms of a with power of u becomes a, and a with power of v becomes b. Okay, Now we can take this and write AB like that, which means that this is going to be A with power of U multiply with A with power of V. Okay. Oh. Now what's happened here? This we can write. Let me write slowly. Maybe write to the right side here. So log base of A, and this will be A U plus V, right? And this is somehow is equal to log A A and then log A V, and we have log or we can say that this is U plus V. Okay. Or maybe if we want to think from here, from the base, and from this exponent. Okay. So A with power of U plus V is the same as, well, yeah, A U plus V. Yeah, it's correct, right? It's correct, just to make sure. You can also look at this property of log. And we have the A over B, we can look that if I have this log A with base A, we can rewrite this and write the inside A over B multiplied with B. Okay, we need to write some separations, and with our first law, the plus one, we can write that this is going to be plus log with base A of B. So the log A over B is equal the log A minus log AB. We just need to move here, right? To make this. And I think for the last one here, for the C, I think we already mentioned in the previous one, so it's kind of natural, supposed to, and obvious. And if you still need some like basic tutorial like the exponent, the logarithmic, or maybe later the trigonometry, my tips, uh, I think you can find um, good videos or maybe good website for more tutoring, especially for basic math, like the Khan Academy. Um, yeah, I think for the basic one, I think this is the best one for the English one. I think for if you want to look for in Chinese content, I think there are several one, but I don't remember the channel name. but I think you can look for it, okay, if you especially for the Taiwanese student, local student, if you want to look. But I think if you check the Khan Academy, they this the website or the video on Khan Academy, they are using I think really simple English, so supposedly to be understandable, so you um, can get the idea from easily from that website. And in the Khan Academy, I think one of the most interesting feature is they have the category, so you are able to look for your course, your level, okay, and then they will provide those course, um, and you can check your understanding each each section. So they will have like a small quiz, like a multiple choice quiz. You can do that if you already learn and then you want to know whether you understand or not. You can check yourself by yourself. Okay, okay. I hope this is helpful. Okay, I hope this can be useful in, especially for students still doing their calculus. I hope this is going to be useful. Okay, next thing is uh, the change of base. Okay, suppose we have b with power of y, let's say equal x. The logarithm, we can use it somewhat, we can use it in mostly in every equations that we are looking in, especially if you have the exponent. Okay, if you have an exponent like this, you have exponent uh, b with power of y, so that is the exponent, right? So we can take log for both sides, and then the idea why we need to take log is we need to take this y into the front, and we can rewrite this into new forms. Okay, so we want to write y is, of course, we with the log definition, this is going to be this, right? But let me just use this take log for both sides. Okay, so if we take log for both sides, let's say we are taking log with base a for both sides. So we can do this, right? So this going down here, so this is going to be y log of a b, right? And this will be log a x, like that. And we can simply write y as log a x over log a b. So the first definition, we write this, and we simply want to say that we have log base b, and this will be x, right? This is the definition. But we can write this into this form, right? So it means we can take the log, and then we can change the base with any base we want. For example, we take a, or maybe if you want to make it more related to calculus, usually we use the ln, right? We use the ln because we have the differentials that is going to be works with ln, right? So that's also one way to think. But how do we make sure that we are understand this as in a logical way? If we put, let's say, if we uh, let x equal a, okay? If x equal a, then log a of a becomes 1, right? So y is become log, let me write a of a, and then this will be log a b. So this uh, log b, let's say this is x, but x is a, so log ba is 1 over log ab. It's interesting, right? It's now it's everything is connected. Log, okay, okay. Now to summarize this, okay, if we have something that has log, okay, a b, we can write this in terms of log b over log a, and let me write this with x as base, which means that you can change x with any base you want, and it still works. It still works. Okay? It still works. Or let's say x is e, it's okay. Become ln b over ln a. It still be the same result. Okay. So from all these things here, and then we can rewrite this, make this property, okay? And then we can make sure that okay, we have this property that is consistent from the very beginning, and we usually call this a change of base. Okay. Okay. Any questions? I think we are going to have the last sections in our topics for exponential and logarithmic. So hopefully you can follow up with more practice and exercise. I believe you can find exercise anywhere. You can find online um, from any textbook you have. If you still have some uh, questions, maybe you are working on some exercise and you're not sure how to solve, you can ask me, you can let me know. At least take the photos. You can take the photos of the questions or screenshots if you are having an online question. Okay, the next last topic, the last sections is the exponential and logarithmic equations. So in these sections, we are expected to solve some exponential or logarithmic equations that we need to solve, okay? And then it can be in any combinations. Okay? So let me give you example, just this example first to see how we solve this question. For example, if you have 5 with power of x and it's equal 125, this is very basic, right? What we need to do is we are going to make this into the same base. Okay? So we are going to have 5 with power of something that is equal to 125. It's 3, right? So this is going to be solved by take x equal 3 because we have the same base. Okay? So the solution is x equal 3. And the same way, if we have 5 with power of 2x, and then we have 5x plus 1. But because we have the same base, we can directly say that this is going to be equal, right? 2x is equal to x plus 1, and x is equal 1, right? I think this is very intuitive, very obvious, right? So let's try to up our questions. So how about if we have 3 with power of x plus 2 equals 7? Now it's not the same base, obviously. It's 7, not 3. If it is 3, it's easy. It's x plus 2 equal 1. So x is going to be negative 1, right? But this is having 7. What we can do now? This is where the log is going to help. Okay? So we take the log, okay, with any base. To make it easy, we take the base 10. So we just take log, just log. Okay? So take log both sides. Okay, and then we are forcing this x plus 2 to be put down. Okay, and it's coming to the front here, and this will be log 3. Okay, equal log 7. So x plus 2 is log 7 divided by log 3. So x is log 7 over log 3 minus 2. And if you want to know how much, you can use calculator for it. But I think just giving the log in our answer is enough. Okay. The same thing if we have the e, like 8e with power of 2x equal 20. What we are going to do? We can take this 8 into the right side and becomes 20 over 8, or let's divide by 4, 5 over 2, or 2.5, it's okay. And then this going to be, take the ln both sides, like that, and we are going to have 2x is equal, and remember, we take 2x here, and ln e is 1, so we can remove that ln e. So 2x is ln 5 over 2. So x is half of ln 5 over 2. Okay. Okay. Now, another type of questions, problem that we might encounter is if you need to write this, I think I can give you a few couple minutes to check. Okay, if you want to take notes. Okay, now let's give you another a type of question. So let's say we have e with power of 2x and then minus e with power of x and negative 6 and then equal to 0. And then we need to solve this. So solve this equation. Now to solve this, sometimes we can rewrite the forms and maybe take sometimes to think that maybe we can take this e to the x. Let's say we take this as a, okay, just another variable. So if we take this as a, so we have a squared minus a minus 6 that is equal to 0, and we are looking at the quadratic equations, right? We are looking at quadratic equation, and this is a factorizable. It is factorizable, so we can factorize this. So a minus 3a plus 2, right? So a is equal 3, a is equal negative 2. But remember that a is e with power x is equal to 3, and e with power of x is equal to negative 2. But remember that this negative 2 is not possible, okay? Because e to the x, if you remember the graph, the graph is saying that this e is going to be higher and higher, and it's never crossing this negative, right? It's never going to be negative. So we are going to have only a positive number that is possible. So x, okay, so x is equal to ln3. So we write here, this is not possible because e with power of x is always positive. Okay, that is if we have in terms of uh, exponent for most part. So the x is in the power. But we can have combinations of x and then also power of x. And to solve that, it's practically not too difficult thing. Let's say we have 3x e with power x plus x squared e with power of x is equal to 0. Okay, first we can take outside x and e to the x. Okay? So we can take e to the x and then take out x, and we have 3 plus x squared. 3 plus x, sorry. This is equal to 0. Now remember that e to the x, e to the x e to the x is never going to be 0, right? Remember that it's never going to be touching this x-axis, right, in e. So we can say that e to the x is never going to be 0. So the possible way is to solve this is when x is 0 and when 3 plus x is 0, or x is negative 3. So this is the solution. Okay. This is just to remind you that e to the x is always positive. So whenever you have this, especially in your calculus functions, you can ignore this e because that is always positive. Not ignore, but you can observe that is always positive. Sometimes it's also become important. So yeah. Okay. So that's about the exponent. Okay. Hopefully I can give you exercise, okay, exercise with some around 10 to 15 questions. um, it's not homework, so you don't need to um, submit that one, but hopefully you can try, okay, at least you can try. And maybe for some questions that I think I need to review, I think I will just give you some additional video about those questions and how to solve, okay, how to solve. Okay, now next part is the logarithmic equation. So this is all about the exponent that we can have as a uh, algebra, okay? In algebra operations, finding the solutions, finding the x. Okay. Now for logarithmic, uh, we start with the just example. Okay, let's start with example. Solve log x squared plus 1 equal log x minus 2 plus log x plus 3. Okay, so to solve this, we are going to need some basic property in logarithmic. So when we have this plus, okay, it means that we can multiply these terms, right, and combine, becoming our log. Okay, and you're still writing log x squared plus 1 like that. Okay, and then let's say we are going to take multiplications for this quadratic equations. So this will be plus x minus 6. This is x squared plus 1. And since we have the same form and same base, well, you can like we change our base formulas. You can make it 2, make it 3, make it whatever. But I think I will just remove that. So that's just the same thing. Okay, so we can write down x squared plus 1 is x squared plus x minus 6. So we solve this, and x is equal to 6 plus 1 is 7. Okay, that's I think very, very easy to follow. Another question is perhaps the most simple one, like ln x equal 8. X is e, like that, right? And if you have log with base of 2 of 25 minus x, this equal 3. It means that 25 minus x is equal to 2 with power of 3. Or this is 8, or we have x is equal 70. Okay. I hope you are able to keep uh, keep up with my explanations. Okay. Because I'm not sure whether you are still watching my videos or not. Okay. I hope you still watch this in this recording. Okay. Next one is solving 4 plus 3 log 2x equals 16. Okay, how to solve this? Well, we could solve this first. Simplify. Divide by 3, it's 4. So we have 2x is, remember, the common logarithm is base of 10. What's happened? Wait. Are you able to see the screen or no? It's still on or maybe blank in your screen? Okay, okay. Okay, good. Okay, so 2x is 10 with power of 4. Okay, I think this is very um, very easy example. So 10,000 divided by 2 is 5,000, right? Okay, another type of questions. Um, solve log x plus 2 plus log x minus 1 equal 1. Okay. If you have this, you have log and you have a constant. This constant here, we need to change this into our log forms. Okay. Remember that 1 is from log 10 because we have base 10 here. So we have log x plus 2, or we can combine this all together, become x minus 1, and this will be log 10. So we can say that we have this is equal 10. So x squared plus x minus 12, and we can factorize this 4 and 3, right? 4 minus 3. So x is negative 4, x equal 3. It seems we finished, but remember, okay, always check, your solution, especially in log, because log, it has some certain domain that can be defined. It can have some undefined interval for its domain, right? So check our solution. So check negative 4. So if we put negative 4, let's say here, sorry, which one? Here. If you put negative 4 here, it's become log negative 2, and this is forbidden in log. Okay, this is wrong. So this is not possible because of domain log, or because of the domain. I think this is still okay. I think for x equal 3, it's supposed to be okay. So 3 here is okay, positive. 3 also here is positive, so it's okay. So yeah, don't forget to check the solution. Okay, any questions so far? Not maybe giving you some practice, maybe 2 or 3 questions, and then we can finish our class today. Okay. So let me give you some exercise to check, just to make sure that we are able to solve some problem. Let me look on. Hmm. Okay. Hmm. Okay, wait. I need to check first. If you have any questions, you can write in the chat box. Looking for some interesting question.
Lu berapa kali share?
Okay. All right. Okay, let me give you some example. Okay. Okay. Let me give you a little bit difficult one. X with power of log to base 2. I think someone's not. X is in between of this, right? To make it define in the domain. The question is solve for X. So it's for find the solution for X. Okay, you can try and we can check later. So I'm giving you a couple of minutes to try. Okay, hopefully. I think X is half, X is 8. Okay, really good, really good. Good, good, Alejandro. That's correct. Okay, I'm keeping tabs on you. One of student keeping mic open. Okay. If you do this for fun, if you not pay attention and fail in the basic math, you need to take again next year. Okay. Please respect your teacher. Okay. I'm not really in a good condition for teaching actually, so please be mindful. Okay. And I know your name. Okay, the one who are opening your mic again and again. Okay, this solutions is basically we take this x squared here first. Okay. So we take that. Okay. And then we are going to take this log here by adding log, because it has base of 2. So we take the log base of 2 for all things here and do the same thing for the right side. So this will be log base of 2 x and multiply with log base of 2 x, right? Okay. And the right side becomes log base of 2 a plus, okay, log base of 2 x squared. Okay. Okay, we can write this log base of 2x and then take squared like that. And log base of 2 of 8 is 3. Okay, so this will be going to be 2 log base of 2x like that. Okay, now this becomes another quadratic equations. Okay, we can take this as a or b or c, anything you can write. So this will be a squared 3 plus 2a, and we can solve this like usual regular quadratic equations. So we can factorize this. Sorry, it's supposed to be 1. So we have a is equal to 3 and a equal negative 1. So log 3, so x is 8, and log base of 2, x is negative 1. X is 1 over 2. Okay. We can check this 8 and half into our equations. We can check to the x, log base to x squared. So we check 8. If we check 8, we are going to have 8 log to 8 squared. So we have 8 cubed, so we have 8, right? If we have half, we can check half. This is half squared, and we have this is negative 1, so this will be 2. This will be 1 over 4. This is also 8. So both are okay. Both are correct. Okay? Both are correct. Okay, that's how you can get the solutions. Okay, let me check whether we have another interesting question. Okay. Okay, another questions. Okay, another interesting question, I think. Solve um, maybe not solve. Find k. So 3 plus 8 log 1 over k, and this will be half square root of 8. This is equal to 0. Okay. Okay. I try to find k. And perhaps this will be the last example, and we can move on to feedback, and I think we can end our class early. Okay. The rest for practice and exercise, I think I will give you on maybe around Friday. Okay. Okay. Anyone can solve? There's one property in log about this 1 over k here, but I think not really uh, important, because we can also using the other property, then we find the same conclusions at the end. So this can be solved by let's write this. Write 8. Just write as it is. And first thing is take this 8 with power of half for the square root. Okay. And then take the half to the front. Okay. So this is equal to 0. So 3 plus half multiplied by 8 is 4. Okay. 4 log and base is 1 over k, and it's 8. Okay, it's equal to 0. Or we can move 3 to the right side, and it's equal to -3. Okay. So log 1 over k, 8, and a -3 over 4, right? And we can just directly write it. 1 over k with power of -3 over 4 is 8. We can write k, since k is with power of -1. Okay, so we can write 3 over 4, and it's equal to 8. Okay, so k is 8 with power of 4 over 3. Now 4 over 3, we can write 2 with power of 3 multiply 4 by 3, divide by 3. Or we could have 2 with power of 4, which is equal to 6. Okay. I will give you more exercise, okay, about this log and exponent, and also some of polynomials uh, for this weekend. And hopefully Hopefully, it can help you to understand more on this subject, especially for your quiz. It's supposed to be next week, the quiz. So yeah, okay. I think I'll stop here. I will stop here, and if you don't have any question, we can move to the feedback. So let me prepare the feedback questions. So I will leave this for you to take notes first for a couple of minutes, and we are going to have a feedback. Okay, I think we can. Let me stop the screen sharing and let me prepare the feedback question. Okay, let me check with my other screen. Okay, can you see the screen? Let me. Okay, and let me wait for a few minutes for you so that you can join the feedback. If you're using the same device with your online meeting, I think you can use the website and go to your browser. Okay. So no need to use the QR code. You can just go to the menti.com and type in the code and waiting for the instructions and waiting for the questions to be pop up. Okay. Okay, let me check how many participants we have. Okay, we have a lot. And we'll wait until around 20 something. Okay, I think we can start. Remember to use your student ID. Okay, student ID. I will wait for a few moments. Okay, I think we can start. There's still some are coming. Okay, let's start now. Okay, possible of positive zeros or positive real root. Okay? Zeros or real root, same. From the polynomial function given is, again, you can just choose which one. Okay. Okay, it means that you are going to use the Descartes rule and just check when it's going to have changing the signs, right? Okay. Okay, let's move to the next one. Okay, let's try. 3, 2, 1, let's go. Yeah, I hope still it's not fine. You need to type the correct answer, not fine. All right. Yeah, 50 seconds. If you pay attention in the first session of the class, I think I mentioned the remainder theorem. This is what it is. The remainder theorem. Okay, 10, 9. Okay, very good. Okay, I think you got the correct answer. Yeah, somebody, one of the students, right? I don't know. Okay. Please check the remainder theorem. Okay, remainder theorem. Okay, last question. Okay, 3, 2, 1. Let's start. Yeah, you need to find the real zero. So find the real root. Okay, and it's supposed to be A, B, C, and D. And A is the lowest. D is the highest. Then you need to sum all the real root, and that's the answer. You can take some time to do some syntactic divisions. Remember that you can narrow your ratios of zeros by the Descartes rule. So you can check the variation of signs. You can check the positive root and negative root. and then narrow to um, specific equations when you do the syntactic divisions, right? Okay, still 3 minutes. There's still 2 minutes 40 seconds. Okay, around 15 seconds. Okay, 3, 2, 1. Okay, I think you guys did a really good job. Okay. Okay. All right, really good. Really good. Okay, congratulations. You're in the game. Who is this? Is it Tannen? Or who? Okay, so congratulations. Okay. I hope you get also good score in exam. Okay. Okay. At the end of course, please write the student ID for your attendance. And if you have any feedbacks, you can write some suggestions. Of course, if you need more review, like from today's course, you can let me know. Next week, we are going to move to other topics, and hopefully, I can give you more exercise and more practice. If you have any questions, you have anything to ask from basic math, and anything related to math course, let me know. It's really good if you have the photos or the screenshot. Okay? So that's it for today. So see you again uh, next week. So next week, I think um, I will just give you content, okay? And next 2 weeks, hopefully we can move in to the class. Okay. All right. So if you have finished, you can leave the WebEx meetings and see you uh, next week. Yeah. You're welcome. You're welcome. You're welcome. Yeah. Sorry, I'm not really feeling well today, so I've decided to go to the class. Sorry for that. Okay, the presentation will be on the Moodle. Okay. Yeah, Tannen, Kevin, right? Okay. Okay. Good. 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 Really good. Okay.